Okay, so this is a question about the calculating the lattice energy for CaO. So lattice energy is when you have an ionic species. So let's say here's a calcium 2 plus ion in a form of a gas fly around, and then the oxygen 2 minus in a form of an ion flies around, and they ended up essentially resting on a lattice CaO solid. And so this is a essential definition of lattice energy reaction. And for ionic compound, ionic solid. So in the energy diagram, I can draw something in a scale. Looks like I can visualize you have this high energy state, and that's a calcium 2 plus gas with oxygen 2 minus gas. That's essentially terms of energy diagram. It's high up there. At the bottom, you expect it to have, as this is a CaO solid on the lattice, and the energy drop on here, we call this lattice energy. So because of lattice energy drops, actually the answer is already narrowed down in among those three choices, and this cannot be. This is an endothermic reaction. That is not true. So the lattice energy concern, the delta H for this should be a negative, and let me just say this is an H here. And there's another one which is called the standard heat of formation, or standard formation energy, and which is shown up here. If you look at that, calcium does exist as a solid, and oxygen exists as a gas, and then this is essentially what we call the pure element in the standard state, and then they form to have this. So this is essentially delta H formation for the CaO solid, right? And in this one, it's saying that it has an energy high up there, and it's kind of dropping down like this. That's a minus 635 kilojoule. And your starting point is calcium solid and a half of oxygen molecule gas, right? So now we just need to figure out there are two tracks that we need to figure out. And the one track is essentially how calcium becomes calcium 2 plus, and the second track is how oxygen becomes oxygen 2 plus. And those are the shown up in the table using up there. So let me use the blue color for the case. So calcium has to be calcium gas, which is a sublimation, and then they have to be ionized. They need to lose the electrons, calcium plus and calcium 2 plus. And so as far as I know, this is a process that the energy goes up. That's a sublimation. So that's a 193. And then this is losing one electron. So that's a 590. And this is 111010. So now we essentially generate up to calcium 2 plus. Okay, what about oxygen? So this is a case showing that two oxygen atom gas reacts to form this oxygen 2 molecule. So essentially, actually the opposite of bond energy. So when they meet together, they form this bond, and this much of the energy is being released. So in this cases, we have this one wants to be oxygen atom gas. So that's the one is essentially actually the full opposite, 498 times half of what we need, right? So this is essentially energy goes up in a way plus 498, which is opposite of that, and you need to multiply by half because only the half moles of O2 gas is involved. And then now looking at this 2-1, which is oxygen gets 1 electron and second electron go, and this is essentially become O2 minus. So this one together is a successive process. You just add them together, which is 8, 7, 8 minus 141. So those are the one together. Now energy goes up and you became the O2 minus. So all these things together is a lattice energy. So the lattice energy should be now as simple as taking from the top and just writing this reaction in a backward, which is minus 1010 minus 590 and minus 193, and which is this opposite direction. So there's a minus 878 plus 141 and minus half of 498, and then this is the same direction. So now minus 635 kilojoule. So putting everything together, that's that lattice energy, and if you do that, you will get this minus 3414 kilojoule, which is the answer for this is an A. Okay. Okay, so this is the same thing as a heat of reaction. We have seen this heat of reaction issues before, and let's essentially remember the heat of reaction is depending on how you write the reaction. So the way that I understand this is, and this is a benzene, there are 2 moles. So 2 moles of benzene, when you react, they will generate 6278 kilojoule are being produced, and so this is an exothermic reaction, right? So now the question is, this amount of heat was produced when you react with a benzene. So I can draw this simple analogy. So 6278 kilojoules are produced, right? It's a ratio relationship when you're having 2 moles of benzene reacted, right? So then I'm asking that we are having 1500 kilojoule are being produced, and that should coming from X moles of benzene, right? So therefore this should be corresponding to the X mole of benzene, which should be 15006278 times 2. So that's a moles of benzene. Right? And then what do you know? Moles of benzene, grams of benzene. Where can I find this? There is a 1. So this is a 78 0.11 gram, and you have a 1 mole. Right? So now this is up to mole. This is up to now grams of benzene, right? So now, but the question is, what is a volume? So I need to change this gram into milliliters of benzene, which is using the density. So up to 5 I have a gram. So gram should go down. Gram benzene and milliliter benzene, and that's shown up here, right? So 1 milliliter will weigh 0.88. Okay, so just getting down to the numbers now. This one is now milliliters of benzene is essentially 1500 times 2, 6278, 78.11 times 1 over 0.88, and that will lead me to getting 42 milliliters. So the answer for this is a D. Okay, so this is a question about measuring the pressure. And if you're looking at this diagram, essentially any points along this should have the same pressure. In particular, this position right up there should have the same pressure. So pressure pressing this mercury in this way is we call ATM pressure. So that's a P ATM. Whereas the pressure point right there is essentially P gas plus rho G delta H. That's the one. They are in equilibrium, so they are having the same pressure. So the question is, what is a P gas? And it says that 8.60 centimeter, which corresponding to 86 millimeter mercury. Right? So that's 86 millimeter Hg, and which is the same as an atmospheric pressure. And the pressure of atmosphere is not 760. In this particular problem was 742, and the torr, and if you look in your reference sheet, this is already said there, torr is same as a millimeter Hg. So it's just the question is, do you know this unit conversion from torr to millimeter Hg? They're the same one. So therefore, P gas is 742 minus 86 Hg. This is a 656 torr. Or somebody says 656 torr. So the answer for this is B.